as h tends to 0 of f of x plus h minus f of x all over h. Now, this question is actually asking you to find the derivative from what? First principles. Okay? The moment you see this expression, limit as h tends to 0 of f of x plus h minus f of x all over h. It's a hint that you're supposed to find the derivative from first principles. Okay? So, okay, so let's do our function is f of x equal to minus 2ax squared plus 2x. Right? Then we write our definition of our derivative from first principle, that is its formula f prime of x is equal to the limit as h tends to 0 of f of x plus h minus f of x all over h. Okay? Then, now since that expression is a little bit complex in terms of it being quadratic, okay, in two terms, it's quadratic in two terms. Let's find f of x plus h on its own. Okay, so f of x plus h will be equal to, we are substituting x plus h here, where there is okay, so this will be minus 2 minus 2a times x plus h squared plus 2 times x plus h. So we have to substitute where there is x here, we need to put x plus h. Okay? So that will give us, now we have to use the knowledge of algebra there. So this will be minus 2a times x squared plus 2xh plus h squared plus 2x plus 2h. This is going to be minus 2ax squared. Can you stop talking a lot, YouTube? Stop that. Minus 4axh minus 2ah squared plus 2x plus 2h. It's quite a long expression, right? It's quite a long expression. Okay, then, now I'm going to substitute that expression into the derivative from first principle, the formula. So, this will be minus 2ax squared minus 4axh minus 2ah squared plus 2x plus 2h minus, then in brackets we put minus 2ax squared plus 2x. This is all over h. Okay? Now, please allow me to just think about some terms here. If I remove brackets, this minus 2ax squared is going to cancel out that minus 2ax squared, because this minus 2x will become positive because of that negative, right? Then this 2x here and that 2x they will also cancel out. Okay? So in the end, we have a new expression. So we have limit as h tends to 0 of minus 4axh minus 2ah squared plus 2h, this is all over h. Okay? Then we take out a common factor there. So our common factor is h. Yes?
So we don't have to write the formula for in this calculation.
Good formula.
The formula.
For the definition of a derivative compressed input, I wrote it already here. There's no need to repeat it because I've written it already. Yeah. Alright. So I'm here, then we take out a common factor. So that will be limit as h tends to 0 of h times minus 4ax minus 2ah plus 2. This is all over h. So okay. So check out these two. Okay. You see, the best way here, it would be to factor out h. If you factor out 2h, it's fine, you get the same result. But because our denominator is h only, you just take out the common factor h. That's fine. These two cancel. Even if you decide to take out 2h, means that 2h, the 2 would be left only on our side of the bracket. Okay? This h and that h will cancel out. So it's fine if you prefer to do it that way. Alright. So from here now, can I move on to the next page? Can I move on to the next page? Can I move on to the next page? Can I carry on? Alright. So this is going to become equal to limit as h tends to 0 of minus 4ax minus 2ah plus 2. Okay? Now I'm going to substitute h equal to 0. So this is going to become minus 4ax minus 2a times 0 plus 2. And the final answer will be minus 4ax plus 2. So our derivative or gradient is going to be minus 4ax plus 2. So what function is that? It's a linear function. Okay, please be aware that this a here is a constant. Okay? The a is a constant. It's not a variable. Our variable here is x. Okay, a is a constant. A is any number. Okay? Right? Any question? Any question? Right, so we found our derivative here from first principle. Then let's move on to B now. So B1 now says determine F3. Now F3 means the value of y when x is 3. So our original function is f of x equal to minus 2 ax squared plus 2x. So f3 will be equal to minus 2a to be minus 2a times 3 squared plus 2 times 3. If you simplify this, you get minus 18a plus 6. Okay? So that's F3. Okay? We are doing that one there. F3 means determine the value of y when x is equal to 3. It's just function notation. It's actually a grade 10 question. Yeah. It's a grade 10 question. Right? Then, number 2, f prime of 3. Okay? F prime of 3 means the gradient of, that function f of x where x is equal to 3. So, we know that f prime of x is equal to this function. Sorry, not the function, but this expression, minus 4ax equal to minus 4ax plus 2. Alright? That's our gradient in terms of a and x. So f prime of 3 means that we have to substitute 3 where there is x. So our gradient will be minus 12a plus 2. Please be aware here that we don't know the value of a, but we know that it's a constant. So that f prime of 3 is the gradient where x is equal to 3 on this quadratic function. Okay, so it's a specific point on the graph where x is 3. Alright, then number 3. Okay, any question? Any question? Right, then number 3, that one there. The gradient of the tangent to f at x equal to minus 4. Now again, this is simple. We found the gradient of the tangent. That is its expression, f prime of x equal to minus 4ax plus 2. Remember, this expression here is also the gradient of a tangent to that quadratic function at a specific point. So if you draw a tangent to this function here at x equal to minus 4, we need to determine the value of the gradient of the tangent at that point, and that value will be the gradient of the quadratic function at that specific point. Yes?
So when you say tangent, what do you mean? Because I know what I'm tangent is circles.
Okay. Sometimes, okay, this is very common in grade 12. Yeah, we did analytical geometry.
Yes.
Yeah, we did. The equation of a circle, we found the equation of a tangent to a circle. So when it comes to a quadratic function, you can have a situation where you may need to know what is the gradient at a specific point, like that. So if I draw a tangent, this is not perfect, right? This is not a grade 11 concept or grade 10 concept, it's a grade 12 concept. So we might need to know what is the gradient at this point. For us to be able to find that gradient, we need to draw a tangent to that point. Then we have to determine the gradient of the tangent. The gradient of the tangent at this point will be equivalent to the gradient of the function at that point. Okay? So this expression here, f prime of x, is actually the general, what can I say, the general expression for the gradient of that function. If we want to find the gradient at a specific point, we just substitute the value of x. Alright? So here, x equal to 4, the way that I did this one here, that's the same that we have to do number 3. So this would be f prime of minus 4.
So this is
Oh yeah, into equal to minus 4a times minus 4 plus 2. And then you get positive 16a plus 2. So 16a plus 2 is the gradient of the tangent at x equal to 4. It's also the gradient of the quadratic function at x equal to 4. Okay? Are you following that? Right? Then number 4 says the rate of change of f at x equal to 2. Remember, I told you, I think it was yesterday, that the gradient is also called the rate of change. Okay? So the way that I did number 2, number 3 is the same as number 4. It's just that the meanings, okay, or rather the meaning of gradient is being changed, okay, from m to f prime of 3, then gradient of tangent is the same, rate of change is also the same. Okay? So if I want to do number 4, I can do on a great page. Okay, right. I don't have a great page. So let me do it on a new page. Right, so number 4, f prime of x is equal to minus 4ax plus 2. Okay? So we want to find the rate of change. Okay? The rate of change of the function at x equal to 2. So what that means is we just have to substitute x equal to 2 into this expression. So the final answer will be minus 8a plus 2. No, it's not plus 2. No. The expression is minus 4ax plus 2. We just substitute the x equal to 2 where there is x. Hey, listen, I'm not sure what you are having a conversation about. We are talking about this. Okay? Okay, Jan, rate of change is the same as gradient. So our expression for the gradient of this function is minus 4ax plus 2. We have been asked to determine the rate of change of f at x equal to 2, which is the same as the gradient of f at x equal to 2. Therefore, we just have to substitute x equal to 2 there. Okay? There is no need to complicate it. Where there is x there, you just put 2 there. And then you simplify. You get minus 8a plus 2 as the gradient or as the rate of change at x equal to 2. Okay? All right?